Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will use radians to calculate the area of sectors and segments. So a sector is like a piece of pie cut out from the circle. A segment is the area between a chord and the circumference of the circle. It's like the sector, but with the area of a triangle bit cut out. So to find the area of this segment, we're actually just going to find the area of the sector and subtract the area of this triangle. So let's look at how we would use radians to do this. So in both cases, we would need to know the angle theta that's subtended. So if theta is in radians, I'll just put that little symbol there just so we know we're in radians. Now we know a full circle is 2 pi radians. So theta in radians over 2 pi, that tells us the fraction of the circle that we're working in. So we know the area of a full circle is pi r squared. So to find the area of a sector, all we do is take out pi r squared and times it by the fraction of the circle we have, just like we would have done if theta was in degrees. So once again, we can do a bit of cancelling. So the area of a sector, if theta is in radians, is just a half times the radius squared times the angle in radians. That's how we find the area of this part here. And as I said before, if we want to find the area of a segment, we just use this formula to find the area of the sector and then subtract the area of the triangle. So let's look at some examples. So let's look at these two diagrams down the bottom. We'll start with this one. In each case, we're going to find the area colored in yellow. So the first one is a full sector, so we just use our formula. The area will be a half times radius squared, so it's 2 meters, times the angle in degrees, and of course 2 pi on 3 is 120 degrees, but of course we're in radians. So if we simplify this in exact form, it would be 4 pi on 3, and of course we're in meters squared, or if rounded, it's about 4.19 meters squared. So it doesn't matter which way you write it, just make sure you read the question properly. All right, let's now find the area shaded yellow here. So this time it is a segment. So what we're first going to do is we're going to find the area of the sector. So we just use our formula. This will be a half times radius squared times the angle in radians. So half times 4 squared times pi over 10. So it's best if we can leave this in exact form for now because we're going to have to end up subtracting. We're going to have to use this answer. So we should get 4 pi over 5. That's centimeters squared. 4 pi over 5 is the area of the whole sector. Now we're going to find the area of the triangle. So we can use half AB sine C because I have two sides and the angle between them. Of course, this side here will also be 4 centimeters because it's the radius. So the area will just be a half times 4 times 4, half AB sine of the angle. So you can write sine pi on 10 radians. You don't need to change it into degrees. You just need to make sure your calculator is in radians mode. Otherwise, this won't be correct. And so we can just write this as 8, because 4 times 4 divided by 2 is 8, of sine pi over 10 radians, and leave that exact for now. So the area that we're interested in is just this answer minus this answer. And so putting that into our calculator to 2 decimal points, it's about 0.04 centimeters squared. We'd expect it to be a very small answer. All right, let's now just do one question that's harder. Please pause and copy this down if you need. So let's have a go at this question here. Once again, I will calculate the area in yellow, which is the area of a segment. So this question's a little harder because I'm not told the radius, nor am I told theta, the angle subtended. Now I can find the radius pretty simply. I know the circumference of the circle is 2 pi r. I'm told the circumference is 100. So radius will just be 100 divided by 2 pi. So that turns out to be 15.91549. I'm writing lots of decimal points here, numbers after the decimal point, because I want to use this in later calculations, and it's probably easier to write like this rather than 100 over 2 pi. So I found the radius. I now need to find theta, the angle subtended. So note theta is in this triangle here. So hopefully you're thinking straight away sine rule or cosine rule. Now I just calculated this side and this side. They're both equal to 15.91549. So theta is in a triangle where I know all three sides. So I can find it pretty simply using the cosine rule. Remember, that's what the cosine rule for an angle does. Finds an angle when you're given all three sides. So theta will be the cos inverse of r squared plus r squared minus 12 squared. Remember, when using the cosine rule for angles, the one that you subtract is the side opposite the angle you're trying to find, and it's also the one that doesn't appear on the bottom. So it'll just be 2 times r times r. So there's no 12 appearing on the bottom because it's the side opposite the one we want to find. So all I need to do now is put that on my calculator. So putting that on the calculator, what your answer will be, the units, depends on the mode that you're in. So if you're in degrees mode, you get an answer like 44.29. Your answer is 44.29 degrees. If you're in radians mode, you should get 0.77 radians. So either way is fine. It would depend on whether the question asked you to give your answer in radians or degrees. So now we've got our answer. I'm going to use my answer in radians to finally figure out what is the area in yellow. So we're going to do that exactly the same way that we found the segment on the previous slide. So we're going to first find the area of the sector. So remember, that's radius squared over 2, or half times radius squared, times the angle in radians. So here, I'm just writing r instead of this number here because it takes a long time to write. And so the answer I get is approximately, you don't have to be exact with these because there's so much rounding, but it's approximately 97.52, and of course it would be centimeters squared because the original measurement was in centimeters. So that's the area of the sector. Now, the area of the triangle. So we're not going to do this any differently than we have done before. So the area of the triangle is going to be a half times r times r. So I'm just going to write a half times r squared instead of writing this out twice. Half times r times sine of the angle between them. So, of course, I'm just going to write it as sine 0.77 radians. My calculator must be in radians because I'm using radians here. And so putting that on my calculator, I get answer around about 88.16 centimeters squared. So, of course, the final area in yellow, I'll just call that area of the yellow, will just be this minus this, which is approximately 9.36 centimeters squared. Okay, so it'll be slightly inaccurate because there was so much rounding, but that will be close to what the area in yellow actually is. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.